In this video, we're going to talk about solving equations and more particularly equations that involve one step and adding and subtracting. So by one step, I mean there's only one um, thing we have to do to find the unknown in the equation. And then at the end, I'll hand out a worksheet for everybody. What I hope you'll understand is the steps to solve a one-step equation, as well as an idea of opposite operations. Let's get started. So the first thing I want to talk about is what is a variable? So, I mean, that's a good question. We have been talking about variables for a little while now, and I thought maybe it'd be a good time to just give maybe a more structured definition. And here we go. A variable is something that can take on any of a set of values. And in our case, those values are going to be numbers. Okay, so a variable is something that can take on any of a set of numbers. So that means there is a bunch of numbers that a variable could be. Um, and that means that it could change as well. We could make that variable be any one of this set of numbers. And so that's our maybe a very loose definition of a variable. So how do we represent a variable? Well, we represent a variable by a letter or symbol. Generally, you'll see X and Y a lot to represent variables, but we could also use Greek letters. Here's a couple of Greek letters. It really, a variable can be represented by anything. And we typically use um, characters like this because they're common. They're useful. We know how to read them. It's better than maybe having some um, like maybe picture of a fish. I don't know, but you could use a fish. That's a horrible picture of a fish. But sure, you could let a fish represent a variable if you wanted to. Okay, so a variable can take on any values in any number in a set of values, and we represent it with a symbol. Okay, so a variable represents a number. We can perform the usual operations of addition, subtraction, multiplication, and oh, I wrote addition twice. That should read um, division. Okay, so because a variable is a number, um, we can do operations on it. Now, because we don't know what the number is, we can't actually perform the operation, but we can write down the operation. So let's say we have a variable x and it's a number. We can certainly add another number, let's say 1, to that equation. All right, so here's a couple of examples. We have x plus 3. Here we have x divided by 5. So if you don't remember some of our notation that we've been going over, we can write this in the following way: x divided by 5. So basically, an x can just takes the place of a number. And we could put any number in there that we want so far. So for instance, this x up here, we could say, well, why don't we let x be 9? And we add 1 to it. Well, we'll get 10. Down here, we can let x be 7. We add 3, we'll get 10. X could be anything, as long as it's a number. Okay, when we put a variable into an equation with an equal sign, then we limit the possible values it can be. Okay, so this part of this equation really influences this variable right here. Now, x just can't take on any value. Whatever x is here, we're adding 1 to it, and whatever the result of that, it has to be 2. So, for instance, x can't just be any number. It can't be a 4, because if we add 1 to 4, Well, it's definitely not equal to 2. We have 5 is equal to 2. That would be bad. That would be madness. So once we've put this equal sign in, x is limited. And in this case, x is limited to 1. The only value x could take on is 1 because 1 plus 1 is equal to 2. And that's it. So you have to, so even though x is a variable, when it's in an equation like this, we restrict the possible values it could take on. Okay? So a lot of the time when you're asked to solve an equation, the goal is to figure out the value or values that x could be. Okay, maybe before we learn a step-by-step process, why don't we just quickly talk about this idea of opposite operations? This is going to be pretty useful in what we're going to do next. So we have our usual 4 operations here. We have addition, subtraction, multiplication, and division. And for each of these, we have something that I like to call its opposite operation. The opposite of adding something is subtracting that same thing. The opposite of subtracting is, of course, adding. The opposite of multiplication is division, and the opposite of division down here at the bottom is multiplication. So these are good things to keep in mind. If you need this chart, keep it in your notebook and make sure you know where it is. But I think most of you can probably remember these. So once again, uh, adding is opposite to subtracting, multiplication is opposite to division, and vice versa. Okay, so let's talk about solving equations. How do we solve for the variable in an equation? Well, the main goal here is to isolate the variable on one side of the equation. What does it mean to isolate? It means to keep apart. So when we say isolate, we could think of it as to keep apart. Okay, so in our context, what we want to do is our variable, we want to keep it apart from everything else in the equation. And this is how we're going to do it. So step one. So step one here, identify the variable. That's always the first thing you should do. You should look at an equation and figure out what the variable is. And for the most part, the variable is going to be a letter or a symbol. In our case, that variable is x. Now, step two over here is to identify the operations performed on the variable. Well, here's our variable, and the operation performed on it is this plus 7. So let's just highlight the plus 7. So that's step two. All right, so first step, identify the variable. Second step, identify the operation performed on the variable. The third step is to rewrite the equation and include the opposite operation on both sides of the equation. Okay, this one's a bit of a mouthful, but let's do this. So here in green, we're rewriting all of the equation from the previous line. So that's this part right here. Now, we're also told to include the opposite operation on both sides of the equation. So I'm running out of colors to highlight here. Let's do this in yellow. We want the opposite operation on both sides of the equation. So the operation is the plus 7. So the opposite of plus 7 would be minus 7. So that's what we're doing on this side of the equation as well as on this side of the equation. Okay, step 4. Perform the operations on the numbers only on each side of the equation. So let's only look at the numbers. So on the equation here, on this side, these are the only numbers. We have 7 minus 7. 7 minus 7 is 0. And on the right side, we have 31 minus 7. 31 minus 7 is 24. So maybe I can get another color here. Why don't we try uh, this interesting green here? All right, so number 4, we are getting these numbers here. And finally, step 5, we isolate the variable. So look at this line right here. The variable is on the left side, and we have this equation x plus 0. Well, if we add 0 to a number, we just get the number itself. The 0 is redundant. We don't need the 0. We could just cross it out if we wanted to. And so we're left with x is equal to 24. There we go. Notice the x is isolated. It's on its own on the left side of the equation. So here x is isolated. Okay. So this is a nice step-by-step guide on how to solve equations, as well as a nice worked example. Now I colored this up a bit for you, but you should have your own notes, and you should be following along with this right now. All right, I'm going to move to a next slide, and let's do another example. I've copied down the steps from the previous slide, and we're going to apply them to this equation here. So step 1 was to identify the variable. Step 2, identify the operation performed on the variable. That's minus 15. All right, step 3, rewrite the equation. So we have x minus 15 on one side. We have equals 93. And we want the opposite operation on both sides of the equation. So we have minus 15. Remember, the opposite to subtraction is addition. So we want to add 15. And we do it to both sides. Let's highlight that in yellow here. Okay. All right, step 4, we perform the operations on the numbers only on each side of the equation. So on the left side, we have minus 15 plus 15. They add to 0. So we end up with x plus 0. And on the right side, we have 93 plus 15 is 108. Once again, the 0 is redundant. We don't need it. So we can perform step 5. X is isolated on the left side, and we have a nice equation that says x is equal to 108. There we go. We have a nice 5-step process that you could follow to solve these one-step addition and subtraction equations. The one step is right here. The rest is just doing some math down here. But this step here is the key step. And when you're adding or subtracting, when you're basically doing the opposite operation on each side. Okay, so let's go to the next slide. This is the one for you to do. It's in your worksheet. I want you to do this one. I've included the steps over here. You can follow along. I want you to do this, solve it, show it to me, and once you've done it, I'll get you the worksheet. Thank you for listening.